Okay, we're learning about complex numbers. Complex numbers are numbers that have an imaginary part and a real part. So a real part is called A, and the imaginary part is B times I. Okay, and you're thinking, well, what is I? Well, I is the square root of -1. So this is what's allowing us to take the square root of negative numbers. So for example, if we want to take the square root of -3, that would be the square root of -1 times the square root of 3. Well, the square root of 3 is just square root of 3, but this would simplify to I. So that we'd have I times the square root of 3. So we would write that as I root 3. Some people will say you've got to put the number part first and then the I. That's okay. I put the I in front because it's really clear then that the I isn't inside the root. But either way, I think is fine. And so here's the actual reality. What we really are doing here is when we take the square root of -3, we also want to include the plus or minus to show that they have two possible roots there. So here's a formula for you. If you wanted to take the square root of a negative number r, some real number r, then you would end up with this pattern. Plus or minus I times the square root of r. And sorry for my pausing. I'm trying to use the same nomenclature as your textbook. So this is what we're going to look at. This is our general rule, and you can find this on page 104. You'll see information about this on page 104. So, for example, if we were taking the square root of -4, for example, that's going to yield plus or minus I, not I, because that's a perfect square. We'll definitely put the 2 here first. So plus or minus 2I. Okay, so that's how we're going to be doing that. If we're taking the square root of a negative number that is not a perfect square, we're going to have plus or minus I times the square root of that number. Okay, so that's how we're going to answer these types of problems with imaginary parts as we solve moving forward. Okay, so this is really what we're talking about when we're talking about pure imaginary numbers. Okay, pure imaginary numbers involving just I and imaginary numbers. But complex numbers have two parts, a real part and an imaginary part. So if you look also on page 103 in your text, you're going to see a chart. You're going to show that all numbers fall into the family of complex numbers. Okay, so if every number is really something that could be recorded or thought of as complex, you would have this branch of numbers that are real, meaning that in this formula, b would equal 0. So complex numbers have this a plus bi shape. And so in this case, for real numbers, the b would equal 0. So there'd be no imaginary part in the real numbers. So a plus 0i. So you would just have some number a. And then you could have pure imaginary numbers as well, which would just be this shape of bi. Okay, so imaginary numbers, where I equals -1. The square root of -1. Okay, and then in our real numbers, we have two types of real numbers. We have rationals and we have irrationals. So rational numbers are numbers that can be written as fractions, where a and b are both integers. So it's a ratio of two integers. So numbers like 3, which is 3 over 1, or 1/2, these are all rational numbers. Irrational numbers can't be represented as integer over integer, some ratio of integers. There are other numbers like square root of 7, which has like I'm going to give an example of this here. Square root of 7. If you were to put that in your calculator and get a decimal version of that, you would see that you would have a non-repeating, non-terminating decimal version of that. So for irrational numbers are numbers that if you saw them as a decimal version, you would see that there's no repeating pattern and the value never ends. So like square root of 7 or pi is another good example of an irrational number. So these are irrationals. All other numbers can be, all other real numbers can be represented as rational numbers, meaning a ratio of one integer divided by another. Okay, and then building from there, we have our integers. And from there, we have whole numbers. And natural numbers. So the natural numbers sometimes are called our counting numbers, like 1, 2, 3, 4, 5. And then whole numbers include 0, 0, 1, 2, 3, 4, 5. Integers include the negative numbers as well, -5, -4, -3, -2, etc. And so that's basically how this. And then we get rational, which often we say are fractions, right? Integer over integer. Knowing that all of these, so the whole number, all natural numbers are whole, are fit into the whole numbers. Whole numbers are all part of the integer group. Integers are all part of rational numbers. Rationals are all part of reals. Irrationals are all part of reals. And then we have our imaginary numbers. And I don't think I actually wrote imaginary in there. I'm going to erase that and write imaginary in that box. And then show that example as BI over here. Okay, so this is our number system with all of its subsets. So complex numbers are kind of up at the top. And probably when you were in kindergarten and first grade, you learned about natural numbers, then whole numbers, then you got older, you learned about integers, then you learned about fractions, then you learned about these special numbers, and you said, oh, these are all real, and now we are learning about these imaginary and complex numbers. Okay, so let's look at a little deeper at our imaginary numbers and our complex numbers and simplifying. So let's do some examples of simplifying imaginary numbers, like the square root of -25, for example. That's going to equal what? Well, that's the square root of 25 times the square root of -1. Square root of 25 is 5. Square root of -1 is I. And so we would definitely be able to take our positive and negative root here, but it's okay if you're just taking the positive root for simplifying. So we'll take the positive root, and then square root of, we'll talk about y later, but for right now, we're just going to simplify with our positive root. Okay, -72, so we've got the square root of 72 times the square root of -1. Square root of 72 is 36 times 2. So we can take a 6 out of that root, leave the 2 in. We still have this times I here for our root -1, and we'll rearrange this so it's really clear that our I is not inside our radical. Okay, so there's a couple of examples of how you can simplify these roots of square roots of negative numbers. Next, we'll talk about examples of imaginary numbers. So here's some imaginary numbers, or sorry, not imaginary. Let's do complex. Complex numbers. Okay, so complex numbers, we've got let's do this. Let's look at how we might use complex numbers in a problem. 2x minus 7i is equal to 10 plus yi. And so what we want to do is we want to find the values of x and y that satisfy this equation. And so what we're going to do is we're going to set these real parts equal to each other, and then we're going to set the imaginary parts equal to each other. So the real parts are this part, real, and the imaginary parts are the parts with the i's. And I'm just going to abbreviate that with IM, imaginary. Okay, so we set these equal parts, real parts equal to each other, so that's 2x equals 10. And then negative 7i equals yi. Negative 7i equals yi. And we go ahead and we solve. And so here we divide by 2. We get x equals 5. Here, what we're going to do is we're going to divide both sides of the equation by I. And so we're left, they cancel each other out. And so we're left with negative 7 equals y. And that just makes sense. Because if negative 7i equals yi, then y must be negative 7 also. Okay, so these are our solutions here. So we get x equals 5 and y equals negative 7. Kind of interesting, right? So then, that's one of our properties, by the way. If two complex numbers are equal, only if the real parts are equal and the imaginary parts are equal. So basically the rule here is a plus bi equals c plus di if and only if a equals c and bi equals di, or more simply, b equals d. Okay, so that's our rule. And then that's basically our rules for looking at complex numbers and comparing two complex numbers and setting them equal to each other. Our next little video is going to go over operations with complex numbers. This is really just an introduction. What are complex numbers? How do they fit into our number system? What are imaginary numbers? How do we take the square roots? And then how do we look at complex numbers and set them equal to each other? What rule do we need to follow to make that true? All right, next video will be on operations, adding, subtracting, multiplying, and dividing.